This lecture is on economic capital and RaRoC. RaRoC is risk-adjusted return on capital. Let me start by giving you an outline of today's talk. I will be discussing first what economic capital actually is, and as a matter of fact, how it's closely related to value at risk. Then let's, very high level, go over the most important risk types if we are considering economic capital calculations. We will be covering these calculations for each risk type first on a standalone basis, and afterwards we're going to add up all the risk together. So we need to figure out a way to aggregate economic capitals for the different risk elements. There will be a diversification benefit because of that, which means that the total required economic capital from all the risk types together, so risk aggregated, will be lower than the sum of the individual ones. Once we have done that, as a second step, we will find a way to allocate capital to risks and to business units. That's then in terms of their contribution to the risk, so what's then the fair amount of capital that they need to hold. And then I will finish the lecture discussing briefly what is meant with the risk-adjusted return on capital. And as a matter of fact, what we will be doing there, we will be stating, well, if you look to a business unit and a business unit contributes to the overall risk of an organization, then this business unit also should contribute to the overall benefit, let's say profit of the organization. And if we take the fraction of the profit of the organization over the risk contribution of the organization, that gives us the risk-adjusted return on capital, and that's a proper measure to see how well a business unit is doing in terms of contribution to the organization and the risk that it is exposed to because of that. Well, what's economic capital? From the perspective of an organization, future, of course, is uncertain, and in order not to go bankrupt, an organization, a financial institution, but also other corporations, they need to have a buffer. They need to have capital set aside for those cases where there will be unfavorable developments in the future, and well, to make sure that these losses that may occur in the future could be absorbed by that capital. What is important is that capital is set aside for a period of 1 year. So we have a horizon of 1 year. And if you think of losses that may occur in the future, then we distinguish between two sorts of losses. The first loss is the expected loss. And the expected loss is something that you reasonably may expect to lose on your portfolio. Think, for example, of credit risk losses. If there's a 1% probability of default in your portfolio, then you expect 1% of your loans to go into default. So that's already expected. So expected loss, we do not see that as a risk. In fact, it's something that also is taken care of, that has been priced for in setting the price of a financial product. What we are interested at are losses that deviate from the expected loss. So losses in excess of the expected loss. So we call them unexpected losses. And unexpected losses is something that you do not expect, but that you still have to cope with. And so it's for that purpose that we set capital aside. There's a distinction between regulatory capital and economic capital. Regulatory capital is imposed, as the word says, by the regulator. It's a standard set of rules which have been developed under the Basel I, Basel II, Basel III, and now there's also Basel IV regulations to determine one-size-fits-all rules for all financial institutions to cover, to determine required capital amounts for different risk types, such as market risk, credit risk, operational risk. And then this as a whole gives a minimum capital requirement. So it's what the regulator says, well, this is at a minimum what you as a financial institution have to set aside. Next to regulatory capital, there's also economic capital. That's the capital that an organization, a financial institution, calculates with its own internal risk models, and there is to some extent, or sometimes to a large extent, an overlap with the models that will be used for regulatory capital calculation purposes, but there may also be many differences. For example, the bank may be more prudent because it wants to say cover a particular credit rating. So for example, it wants to be a AA credit rating type of organization, whereas the Basel Accords, they focus on single A. They may have different ways in determining a probability of defaults, for example, through the cycle versus point in time. So regulatory capital request point in time estimates for the probability of default. A bank may be more prudent or sometimes less prudent by saying, well, I would prefer to have point in time estimates there. So there are overlaps and differences. Usually, the economic capital is more prudent than the regulatory capital, simply also because what a financial institution seeks to do is it seeks to send a message to external funding providers that it's a well-functioning organization with a proper credit rating, so it's safe for external funding providers to provide their funds to the bank. So what the bank does on top of deciding on what model to use and what exactly the contents are of the economic capital models, it also has to choose a credit rating, and that could be, for example, a single A, double A, or triple A rating, and that goes hand in hand with the certainty that it wants to have. So where earlier we talked about the value at risk calculations, where the probability in the tail would, for example, be 1%. Well, with banks, it's either 0.1%, 0.02%, or 0.01% to get to, respectively, a single A, a double A, or triple A rating. So these banks, they try to be very secure so that there is a very low probability of going into default in a 1 year period. And of course, the more certain the bank wants to be in terms of bankruptcy avoidance, the more capital that it needs to set aside, and the lower this probability of default will be. I mentioned it already, so the capital requirements for a bank, so that's the amount that the bank at the minimum needs to set aside to avoid bankruptcy risk, is very consistent with the value at risk calculations. And as a matter of fact, it is the value at risk calculation for the total risk that a bank is exposed to. So really what the bank does, it says, well, there's many different risk types, and I mentioned a couple here, so credit risk, operational risk, market risk. There's also business risk, which we will not include in the, at least in the regulatory capital requirements, which is very difficult to include in the economic capital requirements. But they have identified different sources of risk. And all these sources of risk, they contribute to the potential unexpected loss of a bank. And it's all these risks together and the way that they co-move that may lead to poor results, unfavorable losses. So what the economic capital, or what the capital requirement does, it simply says, well, let's determine a value at risk for the overall portfolio of the bank, and then looking to the aggregate effect of all these alternative risk types that are out there. And let's make sure that we are as certain as stated through the credit rating that the value at risk will only be exceeded with a very low probability. And it's actually the capital that is consistent with that value at risk loss that will be put aside, because then only there is a very low probability that this capital will not be sufficient to absorb losses. So what we will do, it's a couple of steps that we will follow now. We will first briefly review the most important risk types, and the procedure is as follows. So first, what a bank will do, it will determine the required capital per risk type per business unit. Once that has been done, there is the need for an aggregation method to add all these risks up, taking account of diversification benefits. And when we have the total required economic capital, say including all the possible risk and all the possible losses that are out there, and we have determined the certainty level, then the total capital that a bank needs to set aside can be calculated, which is then simply the value at risk that we have calculated. So that's what we will do first. And then as a second step, this total economic capital that has been calculated, the question is then, well, how much of that capital that we need to set aside is because of a particular risk type or a particular business unit? And that's in fact capital allocation that we will do afterwards. But let's start with the individual risks. So what the Basel 2, 3 and 4 regulatory capital requirement models do is they have this bottom-up approach, as I just mentioned, so different risk types, then afterwards you add them up and you allocate to each business entity. We distinguish two types of diversification benefits that are out there. So first of all, if we look to a single contract and a single risk, then the capital that you need to set aside for this single contract and single risk is more than if we would have 10 contracts with this single risk, or 100 contracts with this single risk. So what we say then is that there is an intra-risk diversification benefit, which means that if, for example, I look to credit risk, having a larger portfolio of loans, for example, means that the capital requirements on average will go down because there's diversification benefits, because not all loans will simultaneously go into default. That's what we call intra-risk diversification or within risk diversification. Once we have determined all these intra-risk diversification benefits, so we have then done that for market risk, credit risk and operational risk, and perhaps also business risk, then the second step is to say, well, now that we have the diversification benefits between within these different risk types, let's now also include the diversification benefits between different risk types. So that's what we call inter-risk diversification. And what I mean by that is that if there is a particular contract and this contract is exposed to market risk, credit risk, operational risk and business risk, then it's highly unlikely that if this contract suffers from market risk, that at the same time it also suffers from credit risk or operational risk. So there may be a positive correlation, but it's never perfect. And because there is an imperfect correlation, the correlation is lower than 1, there's also an inter-risk diversification. So also then having multiple risk to be considered simultaneously means that there is again a diversification benefits. And these are the steps that we will follow. So each capital calculation per risk type, then capital calculation between risk types to arrive at a total number. So big review of the 3 most important risk types, to begin with market risk. If we look to the Basel Accord and to the capital requirements that are out there for market risk, then currently what the regulatory capital formula says as well, look to a 10-day period, so that means capital T is 10 days, and look to a 99% certainty level, so that means there's a 1% probability in the tail, and calculate that value at risk. So that's what regulatory capital says. For economic capital, we need to go to a different horizon and possibly also to a different certainty level, because the horizon with capital calculations economic capital calculations is usually a year. So that means that we need to go from 10 days to 252 days. So then the T will be 252. And also the certainty level, so the X, is consistent with the rating of the financial institution. So instead of it being 1%, as it is in the value at risk calculation for the regulatory capital, it may be 0.1%, 0.02%, 0.01%, depending on the rating. And then the capital requirement, as it's stated over here, it says, well, let's look to the amount that I need to set aside. So the value at risk, the way that we always calculated it, was a negative return. So that means this negative return I need to apply to the portfolio value to get a negative amount, a loss. I put a minus sign in front of that so that I know, well, what is then the amount that I actually need to set aside. So minus P times the value at risk. And this value at risk that you need to determine, you really need to have the mean and the standard deviation of the underlying portfolio return for that on a one-day basis. So that's the standard formula as we had it before. So quite basically, say for the intra-risk market risk calculation, we simply do a value at risk calculation. We adjust the time to the time of the period, and we adjust the certainty level, and we make it a dollar amount by multiplying with minus the value of the portfolio. Second risk, important risk that is to be considered is credit risk, and we saw already in an earlier lecture that there is a factor model that could be used and a Gaussian Coppola to get to the Vasicek model. And the Vasicek model, so that Gaussian Coppola that was used there, is exactly the model that is used in practice to do the capital calculations. Well, what goes as input into the Vasicek model? Each financial institution needs to have, for each loan that it has on its book, it needs to do a calculation of a probability of default, a one-year probability of default, and a loss given default assessment. So what that is, well, if a contract goes into default in the upcoming year, and we need to try to recover part of the value. So what is the amount that in the end we will lose on the exposure that we have, given that we're going to default? So these parameters on a quarterly basis, sometimes on a half-yearly basis, a financial institution needs to update, so need to remain very current. Banks have a lot of internal rating systems for them, so both the PD and the LGD, we refer to them as ratings. As the PD is the probability of default rating model, the LGD is the loss given default rating model. So a lot of banks have internal models for them. So for larger contracts, the probability of default for large institutions is also provided by external rating providers such as S&P or Moody's or Fitch, for example. So those are important inputs to the credit risk capital calculation. There's a third variable that's critically important, which is the credit correlation parameter. So the Basel Accord imposes what credit correlation parameter to use there. And what they did is they simply made that correlation parameter a functional specification of the probability of default. A bank could decide for economic capital calculation purposes to develop its own models for that, or simply to decide to also stick with the correlation parameters as they are imposed by the Basel regulations, so be consistent with the regulatory capital calculations. Once that has been done, then the only step that remains is to set the desired rating level and to set then also the associated critical value for the probability in the tail. And simply this is applied then to all loans, leases, and so on the book of the bank. And this determines then the second intra-risk type economic capital calculation. and that's for credit risk. The third risk type is operational risk. And operational risk has to do with failed or inadequate internal processes, with people who misbehave, or with systems that don't work well. Could also be external event, cyber attacks, and so on. So within these type of risks, there's also model risk. So the probability or the risk that a bank uses a model to assess risk or to set limits or to determine prices, and then this model is flawed, it's wrong. Could be legal risk, so that you think that you, as a financial institution, that you have safeguards, and these safeguards in the end are not there. But primarily, so the biggest events of operational risk that have occurred have to do with fraud risk, or with traders circumventing the rules that were set, and then that leading to extreme losses. So it's very typical about operational risk, and then I'm not talking about the ordinary risk that there's small things going wrong in operational processes, but I'm talking about the extreme risk. So events very far in the tail, is that they are of the nature extreme low probability, but an extreme high impact. And of course, from a capital requirements perspective, these are highly relevant because, well, for capital requirements, we look to unexpected losses and we look to extreme unexpected losses, consistent with the rating of the financial institution. But what's difficult is that if then you want to assess operational risk, and you are interested in low probability, high impact events, then it's very difficult to model them because there is no real historical observations that you have for that to do that very accurately. So it's also very difficult to control. It's a difficult risk to assess, but it's out there and it's more and more important. So then, very high level, if you would look to the three risks that were just discussed, so the market risk, the credit risk, and the operational risk, then the market risk is where the Basel Accord started to deal with. So the first capital calculations were for market risk. Typical about market risk is that if you look to the underlying properties of the distribution function, is that the importance of the standard deviation is high. The skewness of the distribution function is almost zero for market risk, and the kurtosis, so that means, well, say the probability mass in the tail of the distribution, is very low. So obviously this was the first risk that would be considered to be modeled, because it's also the easiest risk to model, because really what you need to focus upon is upon standard deviations. So we are not talking about extreme events that are very important, very far on the tail. Second risk type, credit risk. There we see that standard deviation, skewness, and kurtosis, they all have a moderate importance. So it's already slightly more difficult to model this, but as you have seen with the Vasicek model, the Gaussian cupola, we are pretty well able to do that. And then the operational risk, well, we said that's a low probability, high impact type of risk. So that means that very often there will be almost no losses or very low losses. But there are these occasional cases where there will be extreme losses. So standard deviation, importance of the standard deviation very low. Very often there will be not a lot of movement. Skewness, so to the right of the loss distribution, very high. And kurtosis, so probability mass in the tail, very important. And as I've mentioned, the more extreme the risk is, the more important it is. And more extreme means high skewness, but in particular high kurtosis. But it's also more difficult to measure it and hence to model it. So there's where the inconvenience is with looking to risk management and capital requirements if we look to, for example, operational risk. So let's assume that in a first step, we were able to determine these capital requirements when we would consider market risk, credit risk, and operational risk on an individual basis, we would refer to these capitals as intra-risk diversified capitals or standalone economic capitals for each risk type separately. So the second step is to aggregate all these standalone economic capitals. And what we will do is we will assume that they are jointly normally distributed. Also, if they are not jointly normally distributed, the results that we will arrive at are accurate. Because what is important is that in this first step, there was a proper focus on the tail of the distribution. So if in the first step, we used the Gaussian copula and we used value at risk calculations and so on to really cover the capital requirements far in the tail of the distribution function, then in the second step, a sort of variance-covariance matrix approach on these extreme numbers, on these standalone economic capitals, would do a very good proxy to also have then the inter-risk diversified capitals available. So let's denote with EI the economic capital that was calculated on a standalone basis for a particular risk type, for example, for credit risk, or for a particular business unit, or for a particular risk type for a particular business unit, I. And then if we are going to aggregate all these standalone capital requirements to arrive at an inter-risk diversified capital requirement, then we arrive at the total capital requirements for the bank, then what we need to do is we need to take into account diversification benefits. And the way that we do that is that we need to determine, or we need to assume, the correlations between the risks I and the risk J, which I call RaRoC. So we looked at two different sorts of risk types, for example, credit risk and market risk, and we need to understand how they are correlated with each other. So usually how this happens is that it's expert-based, so that there is a committee of wise people that sits together and then they reasonably try to argue well, what relevant correlation parameters are to determine the correlation of capital requirements, something far in the tail. So what it says here is, well, take the sum of all the covariance elements, the correlation elements, and then with respect to the standalone economic capital requirements, and take the square root of that, and that will give you the total inter-risk diversified capital. And I have an example here of that. So this is an example of a bank that consists of two business units, business unit 1 and 2. And both the business units are exposed to three risk types: market risk, credit risk, and operational risk. And in the first box at the top, you see the result of applying the intra-risk diversification formulas to arrive at standalone economic capitals for one business unit and one risk type. So for example, the market risk capital requirement for business unit 1, if we would consider that in isolation, would be 30. For credit risk 70, for operational risk 30. Same for business unit 2, 40 for market risk, 80 for credit risk, and 90 for operational risk. Now, the total capital that a bank needs to hold is not the sum of all these individual intra-risk diversified capitals together, because we also know that these risks will not occur all simultaneously. So there is another diversification benefit, which we call inter-risk diversification. And then the second table that is put on this slide says MR1, CR1, OR1, MR2, CR2, OR2, which really refers to market risk of business unit 1, credit risk of business unit 1, operational risk of business unit 1, and then the same for business unit 2. And what is provided over here is a correlation matrix, which I said earlier could be expert-based. So to what extent do the standalone economic capitals for the different business units and the different risk types correlate with each other? And what it says is, well, if I look to the credit risk and the market risk in business unit 1, then they have a correlation of 50%. And for example, the market risk of business unit 1 and the market risk of business unit 2 have a correlation of 40%. Also what it says is, well, we assume that the market risk of business unit 1 and, for example, the operational risk of business unit 2 has a 0 correlation. These are all reasonable assumptions that you may argue with or not, but as long as they are reasonably motivated, it should be fine. So this is, in a way, this is the correlation matrix that, well, determines the inter-risk diversification benefit. Because if now I'm going to assess, well, what is the risk of all these, what is the total risk if I include all the risks that are available here for all the business units, then what I need to do is I need to multiply the standalone capital requirements from both sides through this correlation matrix. And that's what I've done on the right. I put them at the bottom of the correlation matrix. And then if you do an element by element wise calculation, then you arrive at the matrix in the middle of this slide. Now, how do I arrive now at the inter-risk diversified capital requirement? I need to add up all the numbers in the matrix at the middle of this slide, and I need to take the square root of that. And if you do the calculation of that, that's 203, and I also said that it's 203.224014 unrounded, because that's something that I need a little bit later. I need to have the exact number there. But it says there is then the capital that I really have to hold, that I really need to set aside as a bank, so to deal with the risks in all business units and to deal with all risk types, is 203. And if you remember that we first calculated the capital requirements on a standalone basis per business unit, then the total sum of the 30, 70, 30 and 40, 80, 90 was 340. And now we see that with all the inter-risk diversification, the enterprise-wide capital requirement is only 203. So there is a diversification benefit from the risks not all occurring at the same moment. You could do other types of diversification benefit calculations. In the end, they are all irrelevant, because the only thing that is relevant to begin with is to understand, and that's the most important step that we now have just taken, is how much capital does a bank need to set aside? And that's in this case 203. Then the second question that is relevant is to say, well, now we know that it's 203 that we need to set aside, but what is the contribution of the first business unit to this 203? So to what extent is it responsible for the risk that we bear in the bank? And what we will be doing next is we will use again the Euler's rule that we saw earlier to determine the allocation of this 203 to the two business units. And the way that it works is that is the following. Euler's theorem, Euler's rule says, well, if you look to the total economic capital that we just calculated, which was 203, that really is simple, the sum of all the standalone economic capitals times the partial derivative of the total economic capital with the individual economic capital, the standalone one. And then in a way, that term of EI times Dow E tot over Dow EI, it's what we call the allocated economic capital. And that's a very relevant number, because that says, well, what is the contribution really of business unit I to the total capital that we need to hold. So how much of the risk is absorbed by business unit I? That's the EI allocated. So what is the recipe to operationalize this rather complex formula over there? It's in a way, it's very easy. So how to determine the allocated economic capital? I need to define a small change in the standalone economic capital. So for example, we saw that the economic capital for credit risk of business unit 1 was, I believe it was 30. For market risk it was 30. And what I'm going to do is I'm going to change this 30 in a very slightly higher number, because that's what it says. I need to make a little change in this standalone economic capital. So the Dow EI, ER over EI, that says, well, change the 30, which is in the denominator, with a very small number. And what we will be doing here is we will simply be multiplying it with 0.01%. So that's the XI that we will define. So we change the standalone economic capital, for example, for market risk, from 30 to 30 plus 0.01% times 30. And then once we have done that, we do again the total economic capital calculation as we did on the previous slide. Then we get a slightly different number. And the difference between the new number and the original number is what we call the change in the total economic capital, which is in the numerator of the formula at the bottom of this slide. So that's the change because of this very small shock of 0.01% that we gave to the standalone economic capital. And then once we have calculated that change, we divide it also by the small change, which is the 0.01%, to arrive at the allocated economic capital. So that's simply making the formula on the top of this slide operational. So let's see how that works. So I've done my original capital calculation 2 slides ago. The capital calculation that I did there was, there we arrived at a number of 203,224014. So if I do not round it. And now I'm going to do my capital calculation again. And I want to allocate capital to business unit 1. So what I will do, I will look to the original capital requirements that I had for business unit 1 on a standalone basis. Those were 30, 70 and 30. And I will give them a very small shock of 0.01%. And as you can see, there's the matrix below, which then has on the top a line and on the right hand side a line, and there you see the shocked standalone economic capital. So the 30 has become 30.003, the 70 has become 70.007, and then the 30 has become 30.003. So that's adding a shock of 0.01% to the standalone economic capitals. If then I'm going to calculate all the covariance terms of that, and I take the square root, then I arrive at an inter-risk diversified economic capital of 203,23082, which is just slightly different from the original economic capital that I've been calculating. It's only 0.0068 different. And then this small difference I'm going to divide by this 0.01%, which is a very small number, and which then, where we arrive at is 68.10. So what we have done now is we have calculated the capital, well, the part of the 203 that we have calculated original, how much of this 203 needs to be allocated to business unit 1, and that's 68.1. And what we have done to arrive there, we have looked to all the individual standalone risk capital calculations that were related to business unit 1, and we have given them a small shock. Now, the second part of this table shows very similar results. Here we want to determine the capital allocation to business unit 2. So what we will do is we will take the original capital requirement calculations on a standalone basis for all the risks as we had them. So there were 30, 70, 30 for business unit 1, and then 40, 80 and 90 for business unit 2. And now we will give a very small shock to the standalone economic capital requirements for the risks associated with business unit 2. So the 40 becomes 40.004, the 80 becomes 80.008, and the 90 becomes 90.009. So these numbers are then used to do the covariance matrix calculation with the correlation matrix that we had before. Then we add up all these numbers and we take the square root, and then we arrive at the new capital requirement, which is just a tiny bit higher than the original one, because in this case it's 203,237527 if we do not round it. If I take the difference between this number and the original number that we calculated before we shocked the capitals, then the difference is simply 0.01351, very small. And then this small difference I divide by a very small number, 0.01%, which gives me then the capital allocation to business unit number 2, which is 135.1. And indeed, if you add the 68.1, which was allocated to business unit 1, and the 135.1, which is allocated to business unit 2, if you add them up, then you arrive at the 203.22 that we calculated as the original required capital on an aggregate level, including all the diversification benefits. So you see that this Euler rule is a good way to determine the capital that was allocated to different business units. And you could do similar calculations if you simply want to know, well, what is the contribution, for example, of market risk 1 of business unit 1, and then you only give a shock to that standalone capital requirement. You look what the difference then is on a total level, and you divide it by the size of the shock, and it gives you the contribution. So that's a very nice way to determine how important is a business unit or is a risk as in terms of contributing to the overall risk of an organization, and hence also of the capital that needs to be set aside to cover that risk. Then, because we have done the capital calculations and we know now that this has given us a way to determine the way to understand, well, how risky or to what extent a business unit contributes to the total risk. Then, of course, because capital is scarce, we also have to think very carefully where we want to assign the capital. So, for example, in the previous example, we saw that the second business unit contributes far more to the risk than the first business unit. Then only what you would hope is that the second business unit also contributes more to the profit of the organization. And a way to look to the relationship, to combine the contribution to the profit and the contribution to the risk, is to look to the risk-adjusted return on capital, RaRoC, because what we do in that measure is that in the denominator we put the contribution to the risk, which is the allocated economic capital to business unit I, and in the numerator we look to profit, basically by looking to the revenue minus the costs, and we subtract the expected loss there for business unit I. And then you could simply see, well, the business unit which has the highest number here is the most attractive business unit. So then afterwards that could also mean if the RaRoC is low for a particular business unit, you may decide in your budgeting process for the next round, for the next year, to decide to allocate less capital to this business unit, which also means that they can do lower amount of business, or they are not allowed to grow, for example. So it's a perfect instrument to do performance analysis looking backwards. How well did the business unit do? And then to reward a business unit. But it's also a very neat instrument to do capital budgeting and to tell a business unit for the next year, well, if you want to grow, then that needs to be, say, consistent with the risk that comes with your type of business. And that's all for this chapter. Thank you.